a couple of problems on page 340. On that 6.1, it's word problems, word type problems. So the first one I want to look at is 120. And it's saying the federal debt in 2001 was 3 times 10 to the 12th. Just to let you know that today, this is 2001, today that federal debt is 20 times 10 to the 12th. It has gone up extremely fast. So in 2001, it's 3 times, and I would put 3.0 times 10 to the 12th. So that's $3 trillion. Just in perspective, it's 20 trillion. It's over 20 trillion. Then how much each citizen have to contribute in order to pay off the debt? They're saying 300 million people in the United States. That's men, women, and children. So today, just for perspective, the population is about 320 million. So what do? We would divide the debt by the 300 million. Now, if we write both of those numbers in scientific notation, the denominator would be 3.0 times 10 to what power? 10 to the 8th, right? Now, if we put the 3 trillion in the numerator over the 3 in the denominator, and then go times, and then the 10 to the 12th, that 10 to the 8th would come up, would we add or subtract the 8? Subtract the 8. So 3 over 3 is 1 times 10 to the 4th. Now if we put that in decimal, 1.0, that would be 1 and 4 zeros. So each person back then owed 10,000, man, woman, and child. So, if there's a baby just born, it'd be $10,000. Now today, it's over 6 times that. So it'd be $60,000. So just in perspective. Now, does anybody know the difference between the national debt and a federal deficit? Budget deficit? Well, a budget deficit means that how far the United States government goes behind every year in a budget year. It'd be the same thing as how much do you spend more than you make every year. Now, just in perspective, the last 8 years, the government has spent more than it makes, $1.4 trillion, because they've increased the national debt in the last 8 years by 10 trillion. So their budget every year, we went behind 1.4 trillion. We've doubled the national debt in the last 8 years. We went from 10 to 20 trillion. If we do that again in another 8 years, we'll be 40 trillion in debt. The budget deficit is like you spend more than you make in a year. The national debt is how much do you accumulate over time if you keep spending more than you make. That's the budget deficit. Just if you think about this, you see we were $3 trillion in debt, accumulated debt in 2001. We were $10 trillion in 2008. We're $20 trillion today. So in 2001, from the time the United States was formed until 2001, they'd accumulated $3 trillion in debt. Now from 2001 to 2017, we've accumulated $17 trillion more debt. We have been increasing the budget deficits by a tremendous amount. And that's why they say it's unsustainable. Now here's what's unsustainable. Have you ever heard of the balance of payments? Balance of payments is how much do we buy from foreign countries more than they buy from us. It'd be like Emily and Angie are dealing with each other. And Emily keeps buying more from Angie than Angie does from Emily. So what would happen to Emily's savings? Gradually transfers to Angie. That's what's been happening in the United States over the course of time, because we run a negative balance of payments. We have been transferring our wealth to foreign countries. Now that's why foreign countries can come back into the United States and buy and build in the United States, because they have our money we have given them. And they come back in and they buy us. We sell them a bit at a time what we have by buying more from them than we do from them. They do from us. That's really what's going to get us in trouble. Because eventually foreign countries will own everything we have. Foreign nations will. If we keep doing it. And we're doing it at a rate of something like, I don't know, it's 1% of our budget, and our budget is someplace in someplace in the 15-20 trillion dollars. So if we didn't spend anything in the United States and spent it all toward the debt, we couldn't pay off the debt. National debt. About 1% of that, so about $180 billion we spend more on foreign goods than they spend on us. So I probably told you more than you wanted to know, but all of those numbers would have to be written in scientific notation so we could understand them. So 122. It says, how long does it take light to travel to Earth from the sun? The sun is 9.3 times 10 to the 7th miles from Earth. And light travels at 1.86 times 10 to the 5 miles per second. So what would we have to do to figure out the time? We'd have to divide, right? Divide by 1.86 times 10 to the 5th. And this is miles per second. And our units in the numerator is miles. So if we divide that, what's our units going to be? Notice that in the numerator it's miles, and we're dividing by miles per second. So you invert and multiply, you go miles times seconds per mile. So this is the way you can figure out what units you're going to have. The miles will cancel, and what our answer will be is in seconds. So we'll have seconds is what our answer is going to be. So now if we put 9.3 divided by 1.86, then we go times, and it's going to be 10 to the what? 7 minus 5, right? Now 1.86 goes into 9.3 5 times. 5.0 times 10 to the second power. So if we transfer, and this is seconds, if that goes to units, it's 500 seconds. Now 500 seconds probably is a little bit meaningless to us. So at least if we transferred it to minutes, it'd have more meaning. So how would we do it? How would we transfer it to minutes?
500 divided by 60.
Okay, so we would divide this by 60 seconds in a minute. So if we do that same unit thing, we can see that it's seconds times seconds divided by seconds per minute. We invert and multiply times minutes per second. And our answer would be in minutes, right? So if we divide 60 into 500, it's going to 6 into 50 is what? 8, 48, 20. Now, at this point, we get 0.33.
Yes.
And it just goes on and on. So technically what we have is 8 1/3 minutes. So if a ray of light leaves the sun, 8 1/3 minutes later, it hits the earth. All right. Now what we're going to do is we're going to go into that 6.2. 6.2. Now some things I want to talk about before we do that. Term. Some definitions. A term is a product, that is, you multiply variables or and constants. Where's yours? So a term would be something like 2x or x squared y or 4x squared. You see, it's a product. A term is a product. Now, what we're going to talk about is polynomials. Polynomials. Now, polynomials is what we're going to be dealing with pretty much in this chapter and the next. Polynomials have this nice feature that all polynomials are functions. So for every x, there's one y if it's a polynomial. The second nice thing about it, one, they're functions. Number two is that for every for every x between 2 points, there is a y. That is, there's no holes in the polynomial. Another way of saying that is if you graph a polynomial, and if you have a graph of a polynomial, and if this point's on the polynomial, and this point's on the polynomial, the graph is such that if I start right here at that first point, without lifting my pen off the paper, I can go along the graph of the polynomial. It's called continuous. So it has continuity. Continuous. Now that's a really nice feature, because you see what I've got, if you notice that when I drew this, is I have a point right here, and I have a point right here. That means that I know for certain between those 2 points, it has got to cross the y-axis. There's got to be a point on the y-axis that is consistent with it. Another thing about continuity is, let's just say, for example, I have a point above the x-axis and a point below the x-axis. Because it's continuous, there's got to be at least one point between the two that crosses the x-axis. That's guaranteed, because I can't go to those 2 points without picking my pen off the paper. It's got to cross the x-axis once. Those are important things about polynomials. Now, types of polynomials. There's a monomial. So mono means what? One. So that means one term. Now notice all these things that I wrote right up here are what? Monomials. The second thing is a binomial. Bi means what? Okay, 2, right? So it's the sum, you might say difference, of 2 terms. Now only 2. So if I take 2 of them monomial terms, if I did 2x squared plus x, I have a binomial. If I had x plus 1, I would have a binomial. So, and it'd be on and on. 2 terms, and they're terms, remember, are things that are multiplied by each other, and they're binomials. C is a trinomial. So what is that? 3 terms added. Now, binomials and trinomials are pretty much what we're going to deal with. We're going to have 4, quadrinomials and hexanomials sometimes, but mainly we're going to deal with mono, bis, and trinomials. So a trinomial, typical trinomial might be and so on. Now, another thing that I want to talk about is this. If I had now, this one is written in descending order. That's the way we want to write it. This is an ascending order. We would typically write it as 2x squared plus 3x plus 4. We would write the highest degree term first, next highest, and so on down. So when we say descending order, that's what we mean. Now, if you have a term, there's a couple things that we want to talk about. The term that's in descending order, that is the highest degree term, is called the leading term. So this is the leading term in this binomial. This is the leading term in this trinomial. Now, another terminology that we will use is the numerical coefficient. Numerical coefficient is the real number that is in a term. So that's the numerical coefficient. So if I said the numerical coefficient of the leading term of this particular trinomial, that would be this 2 right here. That's the numerical coefficient of the leading term in that trinomial. So that's the kind of terminology we're going to use. Now, another thing that we want to talk about is things that are not polynomials. Not. The first thing that makes a sum of terms not a polynomial sum is there can be no negative exponents. If it has negative exponents, not a polynomial. So something that would go x, y plus x to the minus 1, that's not a polynomial. It's two terms added together, but it has that negative exponent. Can't have that. The second thing that would not make it, let it be a polynomial, is variable in denominator. So if you had something like x squared plus 2x plus 3 over x plus 1, that's not a polynomial. Now, what that is, this way I've written it, that's a polynomial divided by a polynomial. And that would be called a rational polynomial. We're going to deal with rational polynomials after a while. But that's not a polynomial. And the third thing that makes it not a polynomial is if you have a variable under a radical. So variables under radical. That can't be. So if you had something like x squared plus 2x plus the square root of x, it's not a polynomial. Anytime the variable appears under a radical, it's not a polynomial. But if I had something like this, that's a polynomial. So this is not a polynomial, and this is a polynomial. Because the constant term is the square root of 7. By the way, this is the leading term. It's after you get it in descending order. And this is the constant term. Okay. So those are some things that we need to understand as we go forward with this. So I'm going to do number 2. And here it says you're given this p of x equals minus 3x squared minus 5x plus 8. Is that a polynomial? So automatically, if it's a polynomial, that is a polynomial. You can write it as a function. It's a function. Now they're saying evaluate that at minus 5. Now we've done this before. What it is you go minus 3, and in place of the x, what do you put? So you put minus 5 in place of the x. Wherever it appears. So you see this minus 5 in here says replace this x with minus 5 wherever it appears. And that's what I've done. And then you evaluate that. So this is a minus 3 times minus 3 times 25 minus, this is minus 5 times a minus 5 is a minus 25 plus 8. So that this makes it a minus 75 plus 20 minus. This has got to be a plus. Minus plus 25 plus 8. So these two combined together to give you 50 minus plus 8. So my answer is a negative 42. No, that's all you're doing in those first 6. Is that you probably can do those first 6. Okay, what I want to do is we're going to go around the room and we're going to say this is a polynomial, this one is not a polynomial. Because the instructions say, first of all, which of the following define a polynomial function? So Emily over here is going to start us out. Number 7. Is that one a polynomial? Emily says yes. Everyone agree? Then Angelica, number 8, is that a polynomial? Well, let's just evaluate things that would make it not a polynomial. Let's just say it's a polynomial as long as it don't have what? A polynomial in the denominator. Does it have variable in the denominator? No. So it met that test. Does it have a variable under a square root? No. So it's still a polynomial. So what's the last one? Does it have a variable with a negative exponent? So therefore it's a polynomial, correct? So, Angie.
It's not a polynomial.
Okay, because, Angie?
Because x plus 1 is not in the denominator.
Okay, it has an x in the denominator, variable in the denominator. Jared, number 10, is that a polynomial? Okay, because why? Okay, there's a variable in the denominator. 10, Tristan, you. 11.
Yes.
Okay, now, what we want to do, we want to look at it. What would make it not a polynomial? Does it have a variable that has a negative exponent?
Yes.
No, don't have any negative exponents, does it? So, it's good there. Does that have a variable under a radical? What about that square root of x? We're looking at 11, aren't we?
Yeah.
You see it has a square root of x. It has a variable under a radical, therefore it can't be a polynomial. Does that make sense?
Yeah.
Okay. So that's not a polynomial. I guess he's asleep, so we won't disturb him. Sadie, 13, is that a polynomial?
Yes.
It's how many agree? Okay. That pi is what kind of you have to think about. But pi is just a number, isn't it? 3.1416, 2207, or whatever. So, Maggie, number 14, is that a polynomial? Yes. The tricky one was it had the square root of 7, but that is a real number, right? No variable under the radical, so it's a polynomial. Samantha, what about 15?
That's a polynomial.
Okay, 15 is a polynomial. So 16, BJ, what is that a polynomial? Yes, it is. Now we're back up in front. Emily, is that a polynomial? Yes, it's a polynomial that has a constant term only. Okay, 18. Angelica, what'd you say? No. And what's the reason? No? Okay, there's a variable in the denominator. Very good. Now, what they're asking next is A, the leading coefficient. Now, I think that is not stated correctly. What they want is they want the leading numerical coefficient. Okay. And just by way of example, first of all, it has to be a polynomial. So number 7, we said, was a polynomial. What's the leading term in number 7? Negative x squared, right? See that polynomial in number 7 is equal to a negative x squared plus 3x plus 8. Now the numerical coefficient of the leading term is the number, the real number that's multiplied in that. What is that understood to be? Minus 1 times x squared, right? So A for that is going to be, therefore, Emily, negative 1. That's the numerical coefficient of the leading term. Okay. The B part says, what is the constant term? So Angelica, what is the constant term on 17? It's a term that has no x's in it. Angelica? 8. So 8 is the constant term. And then, what is the degree of the polynomial? Cortez, wake up! Get out of the class. Go. Go. Get out of the class. Get out. Leave. Right now, Mark. That's it. Okay. So any questions? All right. So number 8. Is that a polynomial? Okay. So where did, Angie, was you the, Angelica, was you the last one?
Yeah.
Okay. Angie, what is the leading numerical coefficient? Everyone agree? 3. B, what's the constant term? Jared?
Number 8.
Yeah.
Would be 3 also.
The constant term is what?
3.
No. The constant term is 7.
7.
Okay. See, it's 3x to the 4th minus 3x minus 7. This is the constant term, and this is the numerical coefficient of the leading term. What's the degree? Tristan?
Would it be a -3?
The degree is going to be the term that has the highest power of the variable. Which term? This is a term, this is a term, this is a term. Which one has the highest power?
3x.
3x to the, yeah. So this is the degree of the polynomial. All right? Maggie?
Number 7 and 3.
Number seven, the degree is 2. Yeah. I think I forgot to do that. Okay. Sorry. So we said 9 was not a polynomial, correct? 10, not a polynomial. 11, not a polynomial. 12, not a polynomial. 13 is a polynomial. So, Sadie, in 13, what's the numerical coefficient of the leading term? 3. Everyone agree? B, what is the constant term, Maggie? Pi. That's exactly right. And then Samantha, what is the degree? Okay, does everyone agree on that one? All right. So these aren't too hard, right? 14, we said it was a polynomial, right? So BJ, 14, A is, what is the numerical coefficient of the leading term? Okay, it's -4. Everyone agree? Emily, what is the constant term? 14. Be brave. Yeah, it has one. It's a real number. And that thing is in descending order, so it would have to be
Negative
square root of 7. So that's a real number. And it includes the negative. And it's the square root of 7. The square root of 7 is a real number. So what's the degree then, Angelica? 5. So 15. Was it a polynomial? Okay, let's see. Angie, what is the numerical coefficient leading term?
It's 3.
3. Jared, what is the constant term?
3.
No.
15.
15 is 3x squared minus 5x cubed. You know what? Angelica, we better go back to you. What's the numerical coefficient of the leading term? What's the highest degree term in that one? Okay, so we better revise the 3 and put what? -5. Do you see that? It's the highest degree. It was tricky. It wasn't written in descending order, right? That's why we got sucked into that. Now, which one is the constant term? Jared?
3. Right? There's
No.
3.
The constant term is the one that has no variable in the term. Remember,
Oh, so it's 2?
yeah, each one of these are terms, and this is the constant term. Now, C, what is the degree there? I'm going to go back to Angie. What's the degree?
The degree is 3.
Okay. See, Angie and I both got sucked into saying that the 3x squared was the leading term, and that's not right. It's a minus 5x cubed. And therefore, it's a third degree equation, and we take our leading numerical coefficient from that number, correct? Okay. Now then, 16. Kristen, what, now, is 16, I'm going to ask you a question about this. Is that in descending order? Is the highest degree term first?
No.
Very good. So, which one is the highest degree term, Tristan?
Negative x.
Negative x to the what power?
6.
Sixth. Okay, so what is the numerical coefficient of that term?
6.
That's the exponent.
5. Or 1.
Yeah, a negative 1. It's a negative 1. Do you see that it's a negative 1?
Yeah.
You got everything good. Do you see that? All right. So, Sadie, we are on 16. So what's the constant term?
Is there that one?
Okay, it really has one, but because I want to show you. If I took that particular equation, if I took that p of x, and I wrote it in descending order, it would be like this. Negative x to the 6th minus 5x to the 4th I've run out of time. What I'm going to do eventually